So I want you to have your model and your piece of paper, and let's get rocking and rolling here. Let's just say we've got some aluminum, maybe a little bit of a block of aluminum, and for some unknown reason, we've got a cloud of chlorine gas, which is not something you want to have around because it can kill you. But okay, this is just theoretically speaking, you had some aluminum in some chlorine gas, right? Now, what would happen? So what I've asked you to do in order to be able to predict what would happen is to take your model and look at these patterns of A's and B's. So does this look like any one of these patterns? And I want you guys to unmute your mics, and if you recognize one of the patterns here, say, hey, I think it's this one. Anybody? Now, we're just looking at the first one. Yes, thank you. The first one. The first one is just a something plus a something, and that is the only model that looks like where you've got just one thing here. We recognize that one thing as aluminum, and we've got one thing here. We recognize that as chlorine, disregarding these subscripts here because the subscript is there just because chlorine is a diatomic gas, and we have to have two of those, and because we don't find chlorine atoms floating around in nature all by themselves, it's like they have to have a buddy all the time. So that's diatomic chlorine gas, and it's floating around. Okay, but this is one thing. And another thing, they are going to what we call combine or synthesize a new product, which would be the combination of those original reactants. So it would have to be some combination of aluminum atoms and chlorine atoms. Okay, so here you've just predicted the products based on the fact that you were able to recognize that it follows this model right here. Okay, easy enough, right? When you do predict the products, we need to know that this is an actual thing. Is that a thing? Is aluminum chloride a thing? Well, it sounds like it makes sense, but don't forget what you learned about in nomenclature. Aluminum has an oxidation number of, let's see, probably another thing you're going to have handy is your textbook at around page 616, 617, because we're going to be looking up oxidation numbers. The oxidation number of aluminum is a 3+, and the oxidation number of a chlorine is a 1-. And so aluminum chloride is a thing, but when you write the formula for aluminum chloride, you know that you're going to need 3 of these chlorines to match up with that one to balance out the aluminum, because the aluminum has an oxidation number of a +3, right? So the way that we accommodate that is we put a subscript 3 here, okay? So aluminum in an atmosphere of chlorine will create a new product called aluminum chloride. Notice I didn't just copy the subscript 2 from the chlorine and copy it over here. The subscripts have to be determined on what it takes to make a neutral compound on this side. Okay, we know we needed aluminum, we got aluminum. We know we needed chlorine too. Chlorine, we got chlorine. Okay, now for a lot of these examples, this is obviously not balanced yet. Okay, so what you would have to do to balance this sucker is to play that game. All right, I got 1 aluminum over here, 1 aluminum over here. I got 2 chlorines. Oops, I got 3 chlorines over here. So in order to balance that, I don't know, I might have to put a 2 here and then a 2 in front of aluminum. That would make 6 chlorine, and then I'd put a 3 in front of that one. Okay, so I don't want to bog us down in balancing, but that would be yet another step that you would have to do. And that's one of the things you're going to have to do on your final, because you just can't leave that unbalanced equation there for me. So the final is going to be one problem, but multiple steps. And one of them is going to be balancing, one of them is going to be classifying, one of them is going to be predicting. You get the idea of what the final exam is. It really is comprehensive. It'll be a demonstration of everything that you've learned so far. Okay, So that was the first one. I'm going to be plugging along here a little bit more quickly now that you know kind of what we're doing. All right. So you wrote that example down. I know you guys are keeping up with me with your pencil and paper, right? Okay. So let's take another one. Oh, this looks ugly. There's a lot of things going on here. But come on now. You know that this is just iron and this is just chlorine and this is potassium. And this, you might want to say, oh, well, Mr. A, there's two things there. Nah. You're going to have to be a little bit up on your polyatomics, okay? So you need to be, I didn't, you know what? Maybe I should have made you memorize an entire list of polyatomics. But you should have done enough of these problems that you would recognize that the combination of O and H together is the hydroxide. This is on page 619, table 4 in your textbook. You're going to want to have that with you when you do the final. It's the hydroxide ion right there. Okay, so you don't have three things here. You really just have two. You have a positive cation potassium and a negative anion polyatomic hydroxide ion. So this is following the form AB plus CD. Okay, now look at your foldable, and which one does that look like? Do we have one that has AB plus CD on the reactant side?
The fourth one.
Yes, we do. Okay, so we know that then on this side, the pattern is going to be AD plus CB, whatever those happen to be. And then, so this is like you're decoding a secret code here, okay? So A is equal to iron, D is equal to the hydroxide ion, C is equal to the potassium ion, and B is equal to the chlorine ion, okay? Now, I'm not copying any of my subscripts over. I don't need this model to help me anymore. So now I can just look at this for what it is. This looks like a match made in heaven to me because potassium is, yes, it is. It's a group 1 metal. So it's got a 1 plus. Chlorine, as we said previously, is a 1 minus. So those automatically balance. That work's already been done for us. Put this plus in here because we're talking about two different things. That was in our model. And then, Fe. Fe, this you got to be a little bit careful about because iron is a special ion. I probably needed to tell you that we were talking about this iron. I would have had to tell you if you were given this one for your final exam problem, I would have to tell you that the oxidation number of this iron, that this would be iron 2. Okay, and then that Roman numeral would tell you that this iron has a 2 plus oxidation number. You would look up on your polyatomic list and you would know that hydroxide has a 1 minus oxidation number. So then you would know that in order to form this compound correctly, it would actually be an FeOH2. Okay, now that was a lot going on there because we were talking about polyatomics, we were talking about special ions, we were talking about a lot of things there, but this is where it all comes together. But, you know, if you miss a subscript or something like that, that's 1 point on a multi-point problem. If you can predict it using your foldable, that gets you going a long way, okay? So I want you to get it totally right. Don't mind me, but remember, this is going to be a multi-part problem. Okay, so that was, what was that called anyway? That was called a double replacement reaction. Let me show you one thing that might help you when you're doing these double replacements. They talk about the outers and the inners. Okay, so these are the ions on the outside, and these are the ions in the inside. When you do a double replacement, a partner swap like that, then the outsides are going to go together. So this is FeOH, as we just said, but we know it's FeOH2. And this is K. You got to put the metal first. This is KCl, right? So that's how that goes, right? All right. So I'm just saying, you don't actually have to have the pattern on this side, which was the AD plus CB, if you remember the INI and the outie part. But anyway, maybe that was more confusing than it was worth. Okay. The next one. Okay. Take a look at that. Look at your foldable and see what pattern that might.
The third one.
Ah, yeah, it does kind of look like that, but you'd be wrong. Okay. You would have to classify that one as one of these combustion reactions, a combustion reaction. It does look a lot like a single replacement because we've got the one thing here, and then you would think that, but here's what you need to recognize. Anytime that you've got a hydrocarbon, and that's what this is, burned in the presence of oxygen, that's a combustion reaction. Now, a hydrocarbon is exactly what it sounds like. It's a compound that has hydrogen and carbon in it, and there's lots of different hydrocarbons. So you might see this arrangement with different subscripts, and it actually might, if it's got carbon and hydrogen in it, it's a hydrocarbon. If it's got oxygen on the reactant side, it's a combustion reaction. Okay, now, so you look at your chart and it tells you, you look at your foldable, it tells you what you're going to have for products. This is the one where they actually tell you what you got, CO2 and H2O. So there's no A, B trying to figure out that stuff. It's just CO2 plus H2O. Okay. And we talked about this. You know, if you ever pulled up behind a car and you saw a little bit of drip coming out of the tailpipe, that's not gasoline, that's water. Water is a result of the internal of what's going on inside the internal combustion engine. You're burning some sort of fuel in the presence of oxygen. Air's got oxygen in it. And so this is what you're going to get on the product side after the reaction takes place. Okay. So that's a combustion reaction. All right. So we're building up steam here a little bit. All right. Combustion. All right. We got time for another one. Oh, my goodness. Now look at this. Holy cow. That's a lot going on right there. Let me tell you, the first time you see something with all this kind of stuff going on, what's the busiest looking thing on there? The good old double replacement, right? Where you've got this and this and this and this. We're going to get this whole double replacement going on. Okay? All right. So that means that Al is, so let me give you an example. If this was your final exam problem, I would say, what do you write a complete chemical reaction equation for aluminum sulfite being combined with lead nitrate? And you go, huh? Aluminum sulfate and lead nitrate. That's, you know, we went through the unit on nomenclature. You listen to the words, you can interpret what I just said. Sulfate is a polyatomic ion. You could have looked that up on your list of polyatomic ions. Nitrate is a polyatomic ion. You could have looked that one up, and you know what aluminum and lead are, right? So aluminum sulfate and lead nitrate is going to give you, let's see, aluminum nitrate Okay, don't write the this, you have to bring the subscript 3 along because that's what makes it nitrate. Okay? But you don't bring the 2 along because that's just what was needed in order to make it neutral with lead. Okay? And then you're going to have lead sulfate. Lead sulfate. Okay? Now, then you're going to have to figure out what those subscripts are. Oh, gosh. So you're going to have to go and you're going to have to say, okay, aluminum is a 3 plus, and nitrate is a 1 minus. So you're going to have 3 of those to match up with aluminum. And then lead is a 4 plus. Wow. And sulfate SO4 is a 2 minus. So you're going to need 2 of those to match up with the lead there. Okay. So I formed my compounds. After I predicted my products, you have to form the compounds correctly by writing the subscripts. Okay? That's the other step in that, right? So you will notice if you took a look at the final exam study guide, I gave you kind of a step-by-step procedure on how to do each of these. So it's going to be open book and open note. Make sure you got your book and your notes with you, okay? Including the study guide, which gives you a step-by-step process for completing these. Okay? We're getting pretty good at this now. Now remember, where's my little sign at? This is not necessarily has not necessarily been balanced yet. I don't know. Maybe not balanced yet. Okay. So, I get my YouTube critics going on here. Oh, Mr. A, I'm going to give you a thumbs down because you just showed everybody an unbalanced equation. I'm not worried about balancing right now. I want to make sure that you guys know how to do the products. Okay. Let's take another one. Okay. Now, I want somebody from the studio audience to predict the products of this chemical reaction. Crickets. I hear crickets. Come on, somebody, give it a shot. First of all, somebody tell me what class of reaction this is.
The third one?
The third one. Open up your little foldable and tell me what is the name of that third type.
Single displacement?
Single displacement or single replacement. They're both the same thing. Single replacement. This is what we call the home wrecker. This is the home wrecker equation because we talked about the dance, and this guy right here, he comes to the dance, and this couple goes to the dance, and then what happens? There's usually a metal is going to replace the metal in this ionic compound. Okay. All right. So I think I've said too much. Somebody tell me what we're going to have on the other side. What are going to be the products?
Maybe BA, I2, I2 plus BA, not BA, MG.
Yay! I'm so happy you did it. You just predicted the products of a chemical reaction. You are a chemist. I dub you. This is wonderful. This is everything I ever hoped for obtaining in my whole teaching career. Yes. So you're right. So you're going to have that replacement. That metal barium is going to replace magnesium, is going to kick magnesium out. Okay. Now let's clean things up again a little bit. Barium, oh goodness, I'm going to have to look on my periodic table. barium, the oxidation number, and I closed my book already. The oxidation number for barium, that's not one that we're usually familiar with. The oxidation number for barium, it is a group 2, so it is a 2+, and iodine is a halogen, so that's a 1-. So it would actually be a BaI2. Okay, so you actually said it right, BaI2, and then elemental magnesium is going to be kicked out of it. Yep, that's exactly what's going on. Boy, don't you hope you get that one for your final exam, right? Okay, all right. So okay, I think we have time for one more, and it is going to be exciting. I'm guarantee you, this is probably one of the most exciting chemical reactions in all of chemistry, except for francium and water. Okay. All right. Take a look at that. Somebody help me with this. What are the products going to be of, this is actually called, if I was giving you a word problem, sulfuric acid and potassium hydroxide. Ooh. Okay. First of all, somebody out there classify it for me. What class of reaction is it?
Double displacement?
Yes, double displacement. Yes, absolutely. Because for one, if it's got this many elements in it, it's pretty complicated, right? It's not a simple, and I don't want to overplay that, but a lot of the examples that you're going to get are going to, if it's a synthesis reaction, it's going to be pretty simple. If it's a decomposition reaction, it's going to be pretty simple. This one just looks complicated from the onset. So double displacement, that would be your first hint, and then you would say, okay, I can identify this as one part of it, maybe the A part of it. I can identify this polyatomic, that's my sulfate again, as another part of it. I can identify this as another part of it, and this is another polyatomic right here. Okay, so now somebody out there, ring the bell, rock the clown. Tell me, what are the products of this chemical reaction going to be?
H2H and KOSO4.
Okay, KSO4. Okay, I heard that. Okay, and then you said
H2OH.
H2. Well, forget about the subscript right here.
Okay.
Because that doesn't carry over, but HOH. Okay. Yes. All right. Now we're not quite done yet, but yes, you actually did it. You predicted the products of a chemical reaction. So first of all, KSO4. I forget now. I wish I need to. This is why you're going to have the tables out in front of you, because you're going to be constantly opening up your book. What is the oxidation number of the polyatomic ion sulfate? He asks himself as he flips through the pages. He knows it's going to be right here. Right here. Sulfate is a 2-, and potassium is a 1+. So this is 2- and a 1+. So you're going to need a couple of the potassium atoms to go along with the sulfate. And then here's a little trick. Look at this HOH really hard. What is that? How many H's do I have?
2.
Isn't this just H2O? Whoa! Yes, it is. Yes, HOH is H2O. Okay? So here's the cool thing about this reaction. This is an acid, and this is a base. And you would think that if you mix something really volatile like an acid and something really corrosive like a base, that it would be like this stupendous reaction. You know what you get? Salt water. All right. So that's one of the exciting things that you have to look forward to as you go on in chemistry and concoct these crazy reactions that fizzle. But anyway, I'm really proud of you guys because you were out there doing it. You were actually out there predicting the products of a chemical reaction. And really the key to it all is your secret decoder ring right here. It shows you the patterns. It tells you what the names of the reaction are, explains it to you in plain English, and then on the back it gives you some examples. So the problem that you're working on might actually show up back here. Right. So I would definitely have one of your handy dandy secret decoders right there with you as you do these predicting products. Okay.